So how are you everyone today? Doing good? No comments? At least you could say yes, no. I completed half and I didn't have time to finish the other half. So my plan is to do it tonight.
Okay, so next week,
Let's see.
what the
So the exam supposed to be based on the derivative. So we learned derivative 2.2. My plan is to give it to you next week, Friday,
next week?
because we are done with all the derivative. So initially I was thinking about the week after that. Well, I can give you the test week on the week after that. So if you want to take the test between 17 to 21, no problem. But we have to go over the derivative. So today we'll be done with the derivative, all the derivative. And your exam supposed to be also only on the derivative. So you're done with the, we'll be done with the materials today.
So then the 14th. Oh, wait, no, the 13th. So Thursday, the 13th.
Thursday?
Decide.
Okay.
So you have it on the 24th.
Could give it to 20 or 21, but then you have to go over more materials. If you do it on 13, if you do it on 13, then it's only on the base and derivative. Product rule, power rule, chain rule, quotient rule, and today's new rule. That's it.
All right.
All the derivatives.
13.
13.
But that means like the rotation.
I'm going to post it tonight.
Why not? No, not class.
Some students cannot,
Friday.
but some students cannot take on Friday.
All right.
I think that's their problem.
No, it's 5 students.
So anyone else who cannot take the exam on Friday?
Only
Next Friday?
Any Friday, next Friday.
Yeah, let's do Friday, we got more time.
Yeah, Friday's done.
Anybody who cannot take the exam on Friday?
Only him.
Okay, Salahuddin, you're going to take before Friday.
Yeah, he can take it on Thursday. Raise your hand. That's what I thought. Alright, it's 1-on-1. Alright, the 20th. The 20th then.
20 will be next week.
I don't want more material. I don't want more material.
Then you're going to have more materials.
Okay, so we're yes, it's 14.
Okay, so Salahuddin, you're going to take the 13th and everyone else will take 14th.
Now let's do it, go.
Okay, everyone answer.
Friday.
Who wants to take it on Friday?
Okay, wait. We'll do it like that. We'll take it on Friday.
Who wants to take it on Friday?
Yo, this is crazy.
And who wants to take it on Thursday?
It's only you, dog.
1, 2, 3.
I agree.
Oh, how about the 20th? No, damn much not. This is the 14th.
Can you guys cannot take on Friday? Like you, Pedro.
Only you.
Okay, then
Oh, but you guys.
Thursday.
I need to take it. Pull up on Thursday.
Yo.
We could take it on Thursday.
Next week, Thursday.
Last
Okay.
night, dog.
We don't know on Thursday. Are you able to on Thursday?
No, we.
I'm thinking of Friday. You can take my shirt.
Yo, look, I got a grandma at home, and I gotta take care of her on Thursday. Yo, no man.
Okay, Salahuddin, you're going to take it on Thursday and everyone else will take on Friday.
That's gonna mess me up.
Why? You're going to take it on Thursday, not Friday, on Thursday.
How am I gonna take it? Here?
No, I'm going to make a schedule, not in the class.
Oh.
Okay. So I'll make a schedule for you with someone else. You'll take it with them on Thursday. Huh? Tuesday. Are you sure? Tuesday is No, everyone else will take, everyone else will take on 14th. You cannot take on it. You can take before, but you cannot take after.
Yeah, man.
Okay. And I can give it on the week after next week, but you have more materials to cover.
Oh, no.
Mm-hmm. So if you do it on 14th, then we have, let me actually pull out my calendar, so it will be easier. Okay, so November. I had this thing. So we have 14th, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 classes. So we can go slow with the materials. Plus, I'm planning to do few sessions on calculator. In the final exam, we're going to have 6 or 8 calculator questions. I'm still deciding.
You know how many questions you'll be on?
On what? Exam? No. I didn't decide yet. So my plan is to go over the new derivative rule today. And then until next week, Friday, which is 14th, we are going to do examples of derivative. You already seen many derivative questions. Some of them look easy, some of them are hard. So my plan is to go over all the derivative questions I seen in previous exams so that you can have an idea what to do, how to do them, plus going over some calculator questions. Okay, guys, what happened?
He's trying to show me a weird thing.
Yo,
Show him after class.
yo, after class, bro.
Not now, after class. Okay, so any other question before we start? Do you have them? I already collected them. Oh, I had this something. So the new derivative rule, it's called implicit differentiation.
Why we got so many?
This is the last one. Last derivative rule.
With the ninth one.
Yeah.
It's the
Chain rule.
You wanna open on Friday?
Hmm?
Friday?
Friday what?
You want to do on Friday?
We want our examples on different derivative rules on Friday. Yeah. How are you feeling today? Make sure to watch the recording. Okay, implicit differentiation. Now, if you observe all this time we took the derivative, we had y on one side and all the x value on the other side. So we took derivative and we said derivative of y is dy dx or derivative of y is the y prime. And then we took the derivative on the right side. We said derivative of x squared is 2x, derivative of x cubed is 3x squared, all those things. Now the difference between all those derivative rules we learned and the new derivative rule we're going to learn is that all this time we took the derivative with respect to x and we only took the derivative of x or x term. But from now on, we're not going to take the derivative of only x term. We're going to take the derivative of the x term as well as on the y term. Okay? When you take the derivative of x with respect to x, we don't have to indicate anything. We already assume by default that derivative of x squared is 2x. And we took the derivative with respect to x. We assume that by default. But when you take the derivative of y, you have to indicate that, hey, we took the derivative of y with respect to the variable x. So there is a new concept, a new term we have to use when you take the derivative. It's called dy dx or the y prime. So when do we use the implicit differentiation? When you cannot solve for y or when you want to just make your life easier without solving for y. For example, if you have x squared plus y squared equals 1, you can solve for y and you get this. And if you try to take the derivative, you have to use the chain rule on this. But you don't have to do the derivative using chain rule. You can take the derivative directly without doing any chain rule, just using the power rule in this equation. Okay, so life will be easier because you're using only the power rule, which is easier and simpler than the chain rule. Also, sometimes we cannot even solve for y. For example, these equations. If you try to solve for y, there's no way we can solve that. But the last example, not the second example. We cannot solve for y, we cannot solve for x single. Like sometimes solving for y or solving for x is impossible. So in those cases, we use implicit differentiation. Can I flip my page? Okay, I have so many things, but the main idea here is that anytime we do implicit differentiation, there is an extra term we have to write after you take the derivative of that variable. Especially if you are taking the derivative of y, you have to write y prime or dy dx after you take the derivative. But if you take the derivative of x term, you don't have to indicate that because by default, it's derivative of x respect to x. But for y, we have to know, if it's the derivative of y, is it a respect to y or is it the derivative respect to x? What is derivative? Derivative is the rate of change. It's the rate of change of one variable in terms of the rate of change of the other variable, okay? So you look at the change in one variable based on the change in the other variable. So you have to indicate always. The derivative means you look at the change in x, but respect to what? Respect to x or respect to y? Well, that's why the new indication comes. Respect to anytime you take the derivative of y, you have to indicate y prime, means you took the derivative of the y respect to the variable x. For example, previously we said derivative of x is 1. And now you're saying derivative of y is also 1. But it's not only 1. Derivative of y is 1 and then times the y prime. Why? Because this one we got by taking the derivative of y respect to x. And that indication is indicated by y prime or dy dx. That's the main difference between implicit differentiation and the other type of differentiation. For other type of differentiation, we did not put dx over dx. We only put derivative of x is 1 and then we are done. But now derivative of y is also 1, the same power rule applies. But for every derivative of y, you have to write y prime or dy dx. For example, x squared. Derivative of x squared is 2x, you all know, right? Sending derivative of y squared is 2y. But it's not only 2y, it's 2y times the y prime. What is y prime? It's dy over dx. So difference between x and y is that for x, there is no indication. But for y, you have to indicate that you took the derivative of y respect to the variable x. It's not y over y, it's y over x. So dy over dx. Why do you see y prime equal y prime? This one? Derivative of y is 1 times the y prime. What is 1 times y prime? Is y prime. So derivative of y is y prime. Derivative of y square is 2y based on the power rule and then the y prime for indication. Later, you have to take the derivative of z also. And also you have to take the derivative with t. Like we have so many variables to work with later. So every time you take the derivative of any variable, you have to indicate that the derivative of that variable, we took it respect to this new variable. Okay. Derivative of x cubed is 3x squared. Same thing, derivative of y cubed is 3y squared. But not only 3y squared. After you write 3y squared, we have to put the indication. It's y prime. Means the 3y squared is actually the derivative of y respect to x. It means we are changing the y based on that change in x.
Wait, what is BYD?
It means derivative of the y respect to x. So this 3y squared. What is 3y squared? How did you get that? You have to indicate. We got the 3y squared from y cube by changing the y cube in respect to x.
What do you mean by respect?
When you take the derivative, there are two things changing at the same time. So you're looking at which change, based on which change. Dy dx means we are looking at the change in the y based on changing the x. It's like how much y is changing based on how much x is changing. For x, there is actually an indication.
So that's implicit.
Implicit. Implicit means you have to implicitly state which variable you are taking the derivative of, and
Explicit is
explicit is taking the derivative of x respect to x. Means it's normal one. Implicit means you are working with two variables. So when you take the derivative of x, there is actually indication. Which we don't write. Why we don't write? Because this is what is happening. Derivative of x cubed is 3x squared, and then you put the indication that should be this. You are saying we took the derivative of x and we did that respect to the variable x. But then what is dx divided by dx? They cancel out. That's why the indication for x is invisible, because they cancel out. But for indication for y doesn't cancel out, so it's visible.
also you gotta write that.
You have to write it down because it's visible. They don't get cancelled out. For x, they get cancelled out.
But can you write the Y, I will say Y.
They both are same. Y prime is shorter, dy dx is more longer, but it's, you can see clearly.
I like this.
We're going to do a lot of them.
Derivative of y cubed is the like y prime form, like, is it two different forms written in the same line?
It's not two different form. I mean, it is two different form, but they're the same thing. So some people like to use y prime. Some people like to use dy dx. They both are the same thing.
3y squared or dyx.
So if you have y cubed and they are saying take the derivative respect to x of y cubed. This will be given to you. Find d dx of y cubed. So you have to write it's 3y squared and then the indication dy dx. But if you're too lazy to write dy dx, you can write same thing as 3y squared and then the y prime. This dy dx and the y prime, they're same thing. The difference is that in dy dx, you can see which two variables you're working with, but in y prime, you don't see the two variables you work with.
Gotcha. Can we go find the problem next?
We are given a function or whatever that is. We are given an equation x equals y cubed plus y minus 1. Find the derivative. When we find the derivative, we have to take the derivative of both sides. The derivative, even though they did not mention, take the derivative respect to which variable. By default, we always take the derivative respect to x. Unless they mention, you have to take the derivative respect to any other variable. If no other variable is mentioned, by default, we always take the derivative respect to x. So denominator is always dx. So what is happening here on the right side? Derivative of x is what? 1. And then if you want to put the indication, it's dx over dx. But they cancel out. So it's only 1. And then the other 3. What's the derivative of y cubed? 3y squared, and then you have to indicate that. It's derivative of y, and we took it respect to x. So you're observing the change in the y based on the change in the x.
Wait, what is d over dx times x?
It means what's the derivative of x? D dx means derivative.
Oh, it's 1. Oh,
It's 1. And here they're saying what's the derivative of y cubed, y, and negative 1.
it's plus 1.
So derivative of y is 1, but then you have to write an indication.
Oh, why?
What is this 1? From x or from y? From y. So dy dx.
Like y times.
And then what's the derivative of any number? 0. So we have 1 equals 3y squared dy dx plus only 1 dy dx.
That's it.
And if you don't want to write dy dx, you can write the same thing, or 1 equals 3y squared y prime plus the y prime.
So that's it.
For now, it is. For now, okay? We're not simplifying anything, just finding the derivative. Okay, so either you can write dy dx or you can write y prime. If you take the derivative respect to x, see, dx means derivative respect to x. However, later we are going to take the derivative respect to time. Time. That time we cannot write dx over dx, you have to write dx over dt. You say changing the derivative, changing the x. I mean, you're looking at the x based on time. So by default, we take derivative respect to x all the time, unless they indicate something else. So later they will indicate take the derivative respect to time. That time, this will not be 1 anymore. This will be visible just like these two things. Okay, clear? Here they are saying dy dx, it means derivative of y respect to x, or we can say y prime of x, it means derivative of y respect to x, or you can write d dx of f of x, it means derivative of the function respect to x. That's it.
So in the final, have they used like different notations to try to confuse the taker? No,
No, they're straightforward. So it will be based on, it will be up to you what you want to use, the dy dx or the y prime. But for the time I'm talking about, that will be the application of the derivative. Okay, now you're going to do the actual derivative question. It says find dy dx. It means once you get the derivative, solve for dy dx. Get the dy dx on one side and everything else to the other side.
Are we taking this?
This room,
Or is it like a case?
let me see, I wrote it somewhere. 2009. 9175. Which room is this? 10, right? So our final exam will be, wait, what? 6119.
That big.
I don't know. Why they are changing our room? So it will be till 17, December 17, from 8 to 10 a.m. in the morning. Room number will be 6119. I'm gonna make an announcement later before the final about all this information. Okay, so here it says find dy dx. The easier way to solve for dy dx is that first get your y term on one side and every other term that doesn't have any y on the other side. Then your life will be easier. You don't have to do that, but if you do that, your life will be easier. That means we can get rid of x cubed from left to the right
Hey, why?
to make our life easier.
Also, you need why.
Not y, the y term,
Why?
because you have to solve y dy dx.
No.
No.
The whole thing.
So 4y square is 16 minus x cubed. Leave the y term unchanged, just alone, okay? Why? Because see here, we have double y prime. When you have all the y prime on one side, you can take it out as a common factor. But if you have y prime on both sides, then you have to do more math to bring them together. So if you just put the y on one side, your life will be easier later. So once you have y term together, not the y alone, the y term alone. Then you take the derivative. What's the derivative of 4y square?
Hey, why?
8y, and then dy over dx.
How about what y?
Or 8y y prime. What's the derivative of 16? 0. And you're subtracting derivative of x cubed.
3x out.
3x square.
5.
So this is, no, for x there is no y prime.
Oh, yeah.
This should be dx over dx. But then dx cancel out, so there is nothing there. So this is 3x square.
Oh, so y is dy.
Dy over dx is visible, you cannot cancel them. But dx over dx is cancelable. You cancel them, it becomes invisible.
Dx would be
That's why you don't even write them, because they cancel out anyway. And now the last thing is to get the dy dx alone. So let me actually erase this to save my voice. So to get the dy dx alone, what do you have to do? Divide by 8y on both sides. So we get dy dx is negative 3, negative 3x squared divided by 8y. I forgot the time changed. It is easy. It's not bad.
Are we going to go over the
I will, but not today. So your final answer is this. That's your dy dx. Negative 3x squared divided by 8y. Any question on this one? Pretty easy. In the next example, we have x and y together.
You divide by.
Not divide, you can subtract x. Not x, sorry, x square. You can subtract x square from both sides. So you have xy equals 10 minus x squared.
We don't divide by x.
You don't have to divide by x, but if you want, you can. But you don't have to. So let me show you both methods actually. Method 1. So Johnny suggested to divide everything by x. You can do that. You can do divided by x, divided by x, divided by x.
What's easier? Dividing by.
This question is easier with dividing by x. But you don't have to, okay? It's method 1. So y equals, how do we rewrite this? Remember, you have to take the derivative, we need to see the power. So how can you rewrite this? 10x to the power negative 1. The x from the denominator goes on the numerator with a negative power. And minus, what is x squared divided by x? X. And now we find the derivative on both sides. What's the derivative of y? 1. And dy dx. What's the derivative of 10x to the negative 1? The power rule. Power comes down and then power minus 1. Negative 10x to the negative 2, which turns into negative 10 over x squared. And then derivative of x, 1. dy dt. That's it. So we use the power rule on everything. The derivative of y is 1 times dy dx. Derivative of 10x to the negative 1, you multiply negative 1 with 10, get negative 10. Then you subtract 1 from the power, you get negative 2 power. You cannot leave the negative 2 power. Bring it down. X equals negative 1. So we are not done. We have to do one more part. Actually, let me do it here. So dy dx when x is negative 1. Dy dx for x is negative 1 is negative 10 divided by negative 1 square minus 1. What is negative 1 square? 1. So negative 10 divided by negative 1, negative 11. So this is the derivative, and this is how much we have when x is negative 1.
And like exactly we open close.
I cannot. I'll be in trouble. Let's do this one using second method. Method 2. In the second method, we're not going to divide it by x.
Why?
because we can do it without dividing by x. Or if you try to divide by x, you'll be in trouble.
What's the method?
The new method I'm going to teach you now. So the first step is same, get rid of the x square. If it doesn't have any y. Anything doesn't have y, bring on one side. Anything has y, bring to the other side. So we have 2xy minus y square equals 1 minus x squared. Now, if you try to divide by x, then look what happens in the middle. We get division variable by variable, which is bad. That's why I do not divide by x. If you don't divide by x, then there is another rule, another method. What is this method? How many functions we have here? 2. One is 2x and one is y. There are 2 functions. One is the x function and one is the y function. So you have 2 variables multiplying, means you have 2 functions multiplying together.
We can divide by 2.
If you divide by 2x, look what happens here. See? It's not helpful. It's bad. So do you remember when you are multiplying functions, which rule you use? Product rule. So here you're going to use product rule. Let's say the first function is f, the second function is g. So f is 2x and g is y. We have one term, but since you have 2 variables, they each represent different function. So to separate them. Okay, then what is f prime? 2. And what is g prime? 1, and then y prime, the indication. Anytime it is the derivative of y, you have to write an indication, either dy dx or the y prime. One of them, you must write. So now you're going to apply the product rule. F prime g plus g prime f. Do you remember your product rule, guys? Good job. So what do I write? F prime means what?
B plus g prime f.
So for f prime, how much we have from f prime?
2.
2. You're multiplying by g function. What is your g function? Y. And then plus derivative of the g. Y prime and your f function. What is it, f? Yes. So we can write y prime 2x, but it looks weird. The y prime should be the last digit in your number or in your variable, okay? Even though I wrote g prime f, but I wrote f g prime. In multiplication, the order doesn't matter. So that's the derivative of the first term, 2xy. And we still have to take the derivative of this. What's the derivative of y squared?
2y.
2y? Only 2y? 2y, y prime. The right side, what's the derivative of 1? 0. And you're subtracting derivative of x squared. 2x. So on the left side, you have 2y plus 2x y prime minus 2y y prime. And the right side, we have negative 2x. Which term on the left side doesn't have any y prime?
2y.
2y. So get rid of that. Minus 2y minus 2y. So we have 2x y prime minus 2y y prime is negative 2x minus 2y.
Also, it's not y prime.
And why I did that? Our goal is to get the y prime alone on one side. This is what it means, solve for, get differentiate, means get the y prime.
That's it.
No, is the y prime alone on one side?
Oh, divided by 2x minus 1.
It cannot divide by 2x minus 2y. First you have to do what?
Oh, you have to.
Factor.
Oh,
You factor out your y prime so that you get your 2x and 2y inside your parentheses as a multiplication. Negative 2x minus 2y. Or if you want, you can pull out a negative sign. And then you get 2x plus 2y. Such. So we have y prime 2x minus 2y equals negative 2x plus 2y. And now if you want to get this y prime alone, what do you do?
divided by 2x.
Divided by 2x minus 2y, both sides. So they cancel out, and you're happy. Your y prime is negative 2x plus 2y divided by 2x minus 2. That's your derivative. You're done with the derivative. But you're not done with the question. Can you cancel 2x plus 2y and 2x minus 2y?
Yeah. Oh, should have.
We cannot. Because the sign doesn't match. They're two different signs. And we cannot cancel 2x, 2x, or 2y, 2y because they're in a relationship. Anytime you have plus minus sign next to that, there is a relationship you cannot break.
Wait, what do you mean by one? Wait, one one, two.
It means now you have to evaluate this when your x is 1 and y is 2. How much is the number for the derivative for x1 and y2? So here comes the next step. You have x value is 1, so 2 times 1. Your y value is 2, so 2 times 2. 2 times 1 minus 2 times 2. Substitute your x and your y. It's substitute with 1 and 2. So what do you want the numerator? How much? Negative what? 6. So this is 2 plus 4. That gives you negative 6. And how about the denominator? So we have 2 minus 4, which is negative 2. So what is our final answer? 3. Now this is the number, the slope of this curve at the point 1, 2 is 3. These are easy. You have to remember 2 things. Taking the derivative of y means y prime, must write it down. And then anytime you have variables x and y together, it's product rule. So 2 things. Any question? Any comments? Okay, then try the next one. They're saying what's the slope of the tangent line? What is slope of the tangent line? Derivative. Indirectly, they're telling, hey, find the derivative. So whatever I did on the left page, you're going to do the exact same thing on the right page. And let me take your attendance. Doing the answer, we are going to have one power rule, one product rule, one quotient rule, one chain rule, one implicit differentiation. Definitely 5 of these, plus the questions you did for the extra credit, those type of questions.
Like 5 to 10.
Around 15, I would say.
See?
15.
But it's
Not
like
50,
so long,
15.
on 9 questions.
Huh? Did I give you anything extra?
But what's sad?
Huh?
I was sad to do the edit.
You should. Yeah, you should all go to SAT for
Yeah, like me.
Extra credit.
for extra tutoring.
Oh.
The more you go there, the better your school will be. On the exam.
So I'll be going to tutoring every day.
Really?
Yeah.
Sure? Wonderful. No wonder you're doing great in class.
Yeah.
You know what's so funny?
Is he lying?
No, like, I went one.
But you said you're going there every day.
So I got different tutoring. No, he's not in help.
Either go to SEEK or SAC. Go to somewhere, okay?
Yo, he's not in help. Looks totally honest, though.
I know you're SEEK because I had to report you guys. Yeah. They always make us to,
Yo, he's sick. I haven't totally honest.
what is Kali honest? Or Macaulay?
Yeah,
I don't know. I have the list. Who in this class are in the SEEK program?
it's funny.
No, he's not in the SEEK program.
Yo, he looks like
Yeah.
You can't look like.
You can tell by look. Come on, Jenny. So we have 11-4 today. 11-4. Dominica, Salahuddin,
Yeah, I got this. Yo.
Arsla. If you're done with this one, there is another one.
Let's see, mine is that.
Let me actually put them together. Or maybe I can just erase my page. Yep. And then one more. Do I have more? 1, 2, 3. No, 3 questions. Enjoy them.
We know.
Total 3 questions.
We know.
Okay, so Maxine, Zoe, Jolene,
The first one is easy.
Prince,
Yo, stop the.
Hayden, Ellen, Asir,
I'm not teaching you, dog.
Skyly, I saw you somewhere up there. Alice here, Jasmina here, Alexandra here, Jennifer here, Jessie here, Johnny here, Afiz, Tarin here, Pedro here, Erica here, Jawad here, Ruby here, Sayom here, Dimitri here, Siki here, Amir here, and William. So people who came late, your exam 3 is Friday next week. 11-14, right? Yep, 11-14 on derivative. All these rules you learn from the derivative will be in the exam. So basically today is the last new things we are learning for the exam.
Wait, I have a question.
Mhm.
So, alright, so I got this for this, right?
So you subtracted x squared, good, so you have,
So you find the derivative of this and this.
but you didn't use the product rule, did you?
I did, right?
You did? Oh,
Yeah.
so derivative of two x
Yeah.
is two y squared, and then four y prime good,
Plus 2y.
30 is 0. And then what is this? Derivative of 3x squared?
Oh, sorry, I gotta find this. Okay.
Derivative of 30 and derivative of that. Here's the one from here. To the derivative x.
I got you.
So what x is the line from? Derivative y is my from.
Yo, you have funny though. I'm not sure what to do now. You said something about factoring. Oh, factoring, but two Y. Oh, yeah, Y. Wait, that's. So like, what Y do next? There's only one Y factor.
Really?
Really?
What's the derivative of y?
Oh, it's Y squared two. Like, oh, so it's like negative two Y.
Derivative 3y prime. Derivative 3 and y prime.
Oh, I. 3Y.
3y prime, not 3y. Oh. First problem is 4x. It's not 4x because you take and you what is y squared. So you have something looks like that. I'll do 2xy.
Oh, this is easy, bro. This is easy.
It's y squared, right? All of them is in this. So 2y squared.
Oh, like what? Oh, no.
This is the derivative of x squared.
I find the point again. Oh, points. So that's the 0.31. You sum in. We did that. So why are you looking at my paper then? Yeah. 1,000. Oh, okay.
And then what's the derivative of x y? Oh. This is product rule. And you want to put these two together and this x on the other side. Solution. Then you will see that y prime is not factorial. There will be some x. Huh? Sure. You have 3x squared, what's the 3x squared? 6x, so that's 6x. Oh, plus you have the, okay, the right side.
You're done, I'm done.
And this.
This is the answer, right?
And this. So that on the side.
Yo, we didn't really get that.
I'm on the third one.
I showed me. I gotta go back to Yeah, alright.
What's that feature?
Yo, I'll need help. I got you. Yo, I'll get on it.
Yo, aren't you next to nothing? I think that's too much like.
Oh, I'm taking, what? I'm taking 2,808.
You're on English too, next to the specs of master. You take this.
It's 8.
It's T.
What's C, dog? Yo, what the fuck is T?
Extra help.
Let's not, I'm 8. This is the my help.
You have to do this,
Ooh.
history.
Ooh. You're taking Ed. Yo, can't be talking. You picked the easiest class. I got the hardest class you can roll.
History is what we know.
No, it's Ed is. Wait, what's Ed? What's Ed? Ed. Yeah, that's easy. That's more like sociology. Easy. I'm taking sociology. So like I could have passed that class. Yo, I got you. I am. I'm working on it. The one looks easy.
What's the name to see?
Wait, so you saw it. It's not for this one. That's
Multiply, and then you take out all the numbers and that multiply. Huh? So you're multiplying 2y prime 2x, multiply all of them with 2x. These 2 times 2. 4. Now what is x and 1? 4. Maybe you want that. Then minus 3y prime. Equals. Now this one doesn't really want prime. So move this on that.
Yo, so I got this one. Divide by 2.
And then from this to you draw the
That's the estimate.
no, factor it out.
I think first 1 and 2. This cycles? No, there. Third one, y 2. And then
No, once you keep it on one. You replace x, you need to write that one of the unknown values. No, why did you have your ones together when you go and have the order? So here you have x and y.
yo, go.
That means.
Yo, light word.
Huh?
Light word.
What is like what?
This. It was so easy.
So, here you have x and y together, that is what I'm doing. This one is only y, that is 0, or.
I got you.
Here you go.
Hey, I'll go check out.
No, because you choose part of both. You choose part of both.
These are Boston.
There's no factor, right? That's 2x plus the y squared. You get this right, then the y thing. Then you gotta do the part two times y squared plus 2x plus that. Are you supposed to do that to that? Yo, maybe those are x. No, it's 4x y with the y. Oh, that's what we're going so we should.
Yeah, you're right. Let's say that is 2x.
Oh, I think I got it.
So you will be
Oh.
and then you find F5 and F5 and for this FG until the product.
I think I got it.
So let's do them together, guys.
Hey. You didn't even do it. I did. We got for number 2.
I'm not telling you.
Wait, can you get number 2 though?
2x minus x and y. So you're subtracting, why you're adding to y? Oh, you're adding y.
Yeah. It's
What's the derivative to y?
why? Is it not 2? Oh, 2. Oh, wait. 2y prime. Yo. Yo, Willow.
Okay. Maybe we can do only the left one and then we can do the right page tomorrow. So on the left page, we don't have any y in the first term. So subtract 3x squared. So we have only 2x y squared minus 3y equals 30 minus 3x squared. We are happy except for one case. There is x and y together here. Anytime x and y together, it's product rule. So let's say the first one is f, second one is g. So f is 2x and our g is y squared. So what is f prime? 2. And what is g prime? 2y y prime.
2y. We got that.
And then here comes the product rule. F prime g plus g prime f. So what is our f prime? 2 multiplying by the g function, what is y squared? Plus our g prime is 2y y prime. And we are multiplying by the x function, f function, which is 2x. So basically we get 2y squared plus 4xy y prime. Now minus derivative of 3y. What's the derivative of 3y? Negative 3 and y prime. So it's negative 3 y prime. The right side of the equal sign. What's the derivative of 30?
0.
0. What's the derivative of 3x squared? 6x. So on the right side, we get only negative 6x. Now on the left side, this one doesn't have any y prime. So you subtract this from both sides. And if you observe, you have y prime in both cases. So you can factor it out as a common factor. Y prime. You get 4xy minus 3. And on the right side, you have negative 6x minus 2y squared. If you want to get your y squared alone, you need to divide by 4xy minus 3, both sides. So we have our y prime. Let me write on the page in such. We have y prime equals negative 6x minus 2y squared divided by 4xy minus 3. So this is the derivative. We are done with the derivative, but we are not done with the question. Because the question is saying once you get the derivative, replace your x and y, x with 3, y with 1. So we do y prime is negative 6 times 3 minus 2 times 1 square divided by 4 times 3 times 1 minus 3. So negative 18 minus 2. 4 times 3 is 12 minus 3. So what is negative 18 minus 2? Negative 20. And what is 12 minus 3? 9. Can you reduce? So this is the number for the slope, and the top one is the derivative.
So I made one mistake. Yo, I made one mistake.
So I actually have a bunch of questions for you to try with their answers. You can try them at home.
Wait, extra credit.
Not extra credit this time.
Replace homework.
Huh?
Replace homework.
Replace homework grade. Homework is 15 questions. How can it replace by 5 questions?
There's no like link beyond the homework, right?
We do have a late penalty.
For the homework.
Yeah. I
Come
didn't
on.
know that. I didn't see the setting. I didn't do anything.
I thought you're still, I thought you're still, yeah, take that.
But department did all the setting on my math lab.
How much is it on?
10%.
10%?
What?
Yo, nah, bro.
So try to do it before the deadline. I think everything is open.
Oh, yeah, so
No, because look, like I know people from other classes, like they do my math on it, and they got no due date.
Because the instructor doesn't know how to change the due dates.
I bet then why you change it?
because you know that's.
Yeah.
No, please.
Probably they're new. That's why.
No, please,
I'll get into trouble.
please,
Trust me, I tried once.
please,
I'll get into trouble.
please.
Do all the homework on time for
I
practice.
did all my thingy. No, like if I started doing my homework in time, you don't get deduct points.
I don't deduct points. My math lab does if you do it after the deadline.
No, it
So
don't.
do it before the
No,
deadline.
Look, I submitted like after the deadline, and I still get full credit.
You did?
Yeah, I think so.
So you didn't have penalty?
don't-
Someone else keep complaining like they have penalty, 10% penalty.
Who?
I don't know. Like
Is
I'm
this
taking
not-
3 classes. So I don't know who complained.
Oh,
But people did complain.
I just wanted to apologize because there was like important matters happening. So
Okay.
I had to like leave some on time, but I was getting really stressed, so I just ended up leaving.
Is everything okay?
Yeah, it was just like there's something happening.